In these last two examples, we'll finish it off now. So a tow truck carries a 3,000 kilogram car from rest with a horizontal 5,000 Newton force. The truck and car accelerate together at 2.5 meters per second for 5 seconds to reach a speed of 45 kilometers an hour. How much work is done by the tow truck? So again, work is force times distance. You know the distance, you know the force, which is 5,000 newtons. Look here. So let's look back to our given information now, because we'll need to find the distance. We have an acceleration, v1, v2. Now your velocity is given 45 kilometers an hour. And hopefully you remember from the first unit how to convert from kilometers per hour to meters per second. The quick way of doing it is dividing by 3.6, or you can set up ratios. And if you're unsure how to do that, again, ask in class and I'll take care of that for you. Time is 5 seconds. Find the distance. So look back to your kinematic formulas again. So you have acceleration, both velocities, and time. So you have acceleration, both velocities, and time, and you need to find distance. You can actually use either this formula here or the next one over here. Both would work. Bottom formula here would work as well. We have v2, v1, acceleration, and distance. So they should come back and give you. But I would pick one of these right now. That's what I've chosen. So we'll look back here now. So v1 is 0, the time is 5 seconds, half at squared. Don't forget to square your time. Don't multiply everything through, square the time first and then multiply. You should come back with 31.25 meters. Now that you have the distance, you find the answer should work out to 1.6 times 10 to the 5 joules. Okay, last example. A 52,000 kilogram train slows from 25 meters per second to 14 meters per second in 5 seconds. Calculate how much work is done on the train. And if you take a look through for force and distance, you find that we don't know force or distance. So we need to look back to our given information and find both. So we're given v1, v2, time, find the distance. Give you a moment now, you can look back to the kinematic formulas yourself. And you should find that to get your distance, formula we had used in the previous example, v1 plus v2 divide by 2, or multiply by half, and then multiply by your time. So add your two velocities together, divide by 2, multiply by 5, and the train would move 97.5 meters while it's slowing down. So now we have a distance, so we can take care of that one here. That's done. But we still need to find force. Remember, force is mass times acceleration. So you can put in your mass, but you don't know your acceleration. So again, you're going to need to look back to your kinematic formulas. You now have distance, v1, v2, and time, and find the formula that has acceleration in it. We look here, v2 equals v1 plus at, 14 equals 25 plus acceleration times time, and you should work back. Oops. You should get an acceleration of negative 2.2. Has to be negative because the train is slowing down. So if you come back with a positive answer, you've done something wrong there. So now that we have acceleration, we can put that back into our formula here. multiply it out and get the force that's applied. So 52,000 times negative 2.2, and we have a force of negative 114,000 newtons. 14,400 newtons. Sorry. Now, you've got your force, you've got your distance, put both into the formula. And we should work out to negative 1.1 times 10 to the 7 joules.